What's up, y'all? This is Sean from Math Swap Tutoring, and today I am going to talk about the calculus principle called the chain rule. All right, so before I talk about this, well, I call it a concept, not necessarily a principle. Um, don't forget, if you're actually looking for math tutoring, myself and others on my team are ready to assist you. Go to that link that you see at the bottom of this screen. And then also, if you wanted to kind of stay updated on what we have going on, as far as like, just whatever's going on with MathSwap Tutoring, use that mathswaptutoring.com/subscribe link to subscribe to our email list. Don't forget to subscribe to this YouTube channel as well, and like and share this video if it's been helpful to you. All right, so let's go ahead and get into this. All right, so let me give me a second here because I have some notes I want to refer to. So the chain rule is a way of finding the derivative of a certain type of function. Okay, so the chain rule, and it'll probably be better for me to type this because I can type faster and I can write. So the chain rule is a method for finding the derivative. Now, if you don't remember about how to find a derivative, make sure you look at my video on that. But it's a method for finding the derivative of a function when you have a function within a function. Okay, so it's just a way of finding the derivative of a little bit more complicated function whenever you have a function that's nested inside of a function. So basically, um, the way that the chain rule works is like this. So if you're taking the derivative of function f with respect to x, that's going to be equal to df du times du dx. Again, so basically what this is saying is, so you have some function f, but the function has a function on the inside of it, u. And so to find the function of f with respect to the variable x, which is associated with function u, you take the derivative of the outside function df du times the derivative of du dx. Now, so let me say it this way. So basically, to find the derivative, you multiply the derivative of the outside function times the derivative of the inside function. Now, that probably just sounds like a lot of gibberish without an explanation, without an example. So let's show it. All right, let's show an example is what I mean. So say, for example, you have this here. You want to take the derivative with respect to x of the following: 2x squared minus 5 to the 5th power. Now, at first glance, looking at this, you take the derivative. Usually when you take the derivative, you take the outside. If you have like a exponent like this, that comes to the front, and then you subtract 1 from that exponent. But then we have this situation here where you have a function on the inside as well. So this is what we're going to do, and I'm going to do this example 2 different ways. One is a slower way, but it's a little bit more thorough so you can see what's going on. And then the other way is going to be quicker. It's the way that I prefer, especially because I've been used to doing this for a while, and it's the way that I learned. All right, but anyhow, so what we're going to do is, so we have a function inside of here, but then there's also the outside function. So you can see it better, we're gonna find 2 functions. So we're gonna call this inside function u of x, and that's gonna be equal to 2x squared minus 5. That's the inside function. Now there is an outside function, which is, we're gonna call that f of u. So basically, that is gonna be u to the 5th. So basically what happens is, to determine what the outside function is, we let that inside function be u of x, or u, and then it's being raised to the 5th power. And then, of course, the inside function, u of x, is u as a function of x. The outside function, again, is with respect to u. We just let this be equal to u, okay? Now, so the derivative, as we said here, the derivative of the function with respect to x is going to be derivative of f with respect to u times the derivative of u with respect to x. So let's find that derivative. So that's going to be equal to, what is df du? What's the derivative of u to the 5th? That's going to be 5u to the 4th. Okay, easy enough. Now we're going to find the derivative of u with respect to x. So that's going to be times, and then you have the derivative of this term. That's going to be 4x. And remember, the derivative of a constant is just 0. So that's it there. Okay. All right. So now what we do is we're going to substitute back in, what is u? U is that inside stuff. So let's substitute that back in. So that's going to be equal to 5 times 2x squared minus 5 to the 4th power times 4x. Now let's bring it all together. So that's going to be 20x. That's 5 times 4 is 20, and then the x is there, times 2x squared minus 5 to the 4th. So it's not that bad. It's not that bad. All right, now let us take the derivative of the same example again. Excuse me, but this time I'm going to do it a quicker way. Remember, at the end of the day, the chain rule is the derivative of the outside times the derivative of the inside. Okay, let me write that. Derivative of the outside times the derivative, pronounce my words, derivative of the inside. So make sure that you remember that. That's the way that I remember learning it way back when I was in high school. All right. So let's write this down again. So the derivative with respect to x, 2x squared minus 5 to the 5th. So we're going to do the derivative of the outside first. So that's going to be 5 times 2x squared minus 5 to the 4th. Okay. Times the derivative now of the inside, which is just 4x. So that's going to be equal to 20x times 2x squared minus 5 to the 4th. And as you see, my answers match up. Okay. So I prefer the second method, but it's more so, I think, I've been doing it for a while. So, and I think that's how I learned. But I encourage you to substitute in if that actually makes it more clear to you. Whatever it is that makes you be able to see it most clearly, that's what you need to do. All right, let's do one more example. And then we'll, let that be it. So I'm just going to take the time to erase because I do want to leave some of these notes up here. I always recommend that whenever you're doing math, that you keep your notes open. That's how I used to do. And even now, as I'm doing this with you guys, I have my notes open here to refer to so that I don't, slip and do something weird or something like that. All right, so let's take the derivative. No, I don't want that color. I just want good old black. So the derivative of the square root of t cubed minus 8. All right, so the first thing to remember is, since we're taking the derivative, we need to remember that how the exponent stuff works when it comes to like roots. Remember that whenever you take the root of something, it's going to be, what a square root specifically is just like taking something to the 1/2 power. So this can be rewritten as dt of t cubed minus 8 to the 1/2 power. Same thing. All right, now, so I'll do the longer method again, just for the sake of clarity. So the outside function is going to be u to the 1/2. The inside function, u of x, is going to be t cubed minus 8. Okay, so the derivative of f is going to be 1/2 times u, and when you subtract 1 from 1/2, that's going to be minus 1/2. The derivative of u with respect to x is going to be 3t squared. So let's see. So the df dt, remember that's going to be equal to df du times du dx. Oh, I said x and then I wrote t. So df du was 1/2 u to the negative 1/2. And then u of x, the du dx is 3t squared. So now before I substitute u back in, I'm going to go ahead and kind of clean that up a bit. So remember, if you have a negative power, then that means that in this case, this variable is going to come to the denominator as a positive power. So that's going to be 1 over 2u to the positive 1/2 times 3t squared. Let's clean it up some more. So u to the 1/2, I'm just going to go ahead and change that back to a square root. So it's going to be 1 over 2 square root of u times 3t squared. Now finally, let's bring it all together. The numerator, 3t squared over 2, and then u was equal to t cubed minus 8. Now I know you might be thinking, okay, there's a square root in the there's a radical in the denominator. And sure, that would usually be an issue, but because of this type of problem, the main thing that we're trying to do right here is just take the derivative. That's what's most important here, so you don't have to worry about that this time. But yeah, you're right. Usually you wouldn't want a radical in the denominator. Anyhow, I hope this has been helpful to you. Make sure that you pause it whenever you need to pause it. Make sure that you follow the rules, follow the examples very closely. And again, if you need tutoring, use the link in the description or on the screen. Subscribe to our email list, and don't forget to subscribe to this channel. Like and share this video, share the channel, and make sure that you join me next time. I hope you guys have a great day, and I hope you'll stay on this channel.